VCE Chemistry, Unit 3, AOS 2. Today we'll go into Chapter 8 and talk about equilibrium. Okay. So, from the study design, we need to know the distinction between reversible and irreversible reactions, and between rate and the extent of a reaction. So today what we'll do is we will look at an equilibrium using collision theory that we already know. Okay. So collision theory states that a chemical reaction happens because reactant particles collide with sufficient energy and correct orientation to form products. However, product particles don't just stand still. They also move around and they will collide into each other. So when product particles also collide with sufficient energy and correct orientation, then they become reactants. So that is as if a backward reaction is happening even though the forward reaction is happening at the same time. So to the observer, then this reaction is what we call reversible. So forward reaction and backward reaction will happen at the same time. So how does this happen? Let's refer to a rate versus time graph. Okay. So initially you will have, if you have a look, you'd realize that a nitrogen and hydrogen reacting to form ammonia. So the forward reaction happens as reactant particles collide and with sufficient energy and correct orientation. Then the rate of that forward reaction will start at maximum and gradually declines as more reactant particles are now turned into products. So according to collision theory, if the concentration of reactants decreases, then the rate of reaction will decrease. At the same time, when particles once formed, they also start to collide to produce reactant particles. Okay? So the reaction rate starts at minimum for this backward reaction, and gradually as the forward reaction, as the products form, the backward reaction rate increases because more product particles are available now. Okay. So ultimately they will reach the same rate, which is that the reaction of forward reaction, the back reaction will happen at the same rate. Then to our observer, there is no change to the reaction system from that point onwards. It does not mean that this reaction has stopped because the rate is not zero. The forward reaction keeps happening. The backward reaction also keeps happening because the rate of both reactions are now the same. So we can't see any change to the reaction system. And that state is basically the end of the reaction for a reversible reaction. And we call that equilibrium. Okay? So when forward reaction rate and backward reaction rate are the same, then the equilibrium is established. So a double arrow then is used to represent an equilibrium system. Okay, so for a reversible reaction to actually happen, we must make sure that products and reactants must stay in contact with each other so as to achieve equilibrium. Okay, and therefore an equilibrium can only be achieved, or a reversible reaction can only happen in a closed system because the products cannot leave the reaction system. Okay. One example is referring to the rechargeable batteries. One of the criteria for rechargeable battery is that for a battery to be rechargeable, the products of discharging must stay in contact with the electrodes so that the same reaction of backward reaction can be initiated. So now let's have a practice. So when a 2-propanol reacts to form an equilibrium mixture to form propanone and hydrogen, and therefore a backward reaction will also happen, then which one of the following will best represent how the rates of reaction forward and backward change over time? Okay, so we know that for an equilibrium to be established, the key feature is that the rate of forward reaction should equal to the rate of backward reaction. That means on this rate versus time graph, the two lines should meet in the middle. That rules out A and B. So C and D, which one should we go with? The only difference is that which one is the forward reaction, which one is the backward reaction, and which one is decreasing and which one is increasing. So if the forward reaction is 2-propanol to decompose into 2 of its components, then it should be D, because then the rate of decomposition will decrease, and of course the reaction of these two to form reactants will then increase. So the answer is D.